Thanks for inviting me. It's nice to see everybody here. I can see from people's backgrounds that you're a technical bunch who likes to tinker and build and learn about new stuff. So excited to share with you. Yeah, this first slide is making me a little seasick too, so let's get past that one. So I want to talk to you today about KV4P HT. That's my call sign, KV4P. Kilo Victor 4 Papa. Name is Vance. I live in Durham, North Carolina. A few basic things that kind of come up every time I talk about the project that I just want to get out of the way. So we were kind of talking before the presentation a little bit. It's a fully open source project. I decided not to try to make any money off of it. I just wanted to get people excited about this kind of thing, get them involved, maybe get them to think about ham radio in a slightly different way. So it's fully open source. I don't make any money from it at all. It's cost me a lot of money to order prototypes and get the PCBs working and everything. So, as a result, there's not like any support for it other than community support and things like that. But there's a lot of community support, so that's not necessarily a bad thing. It fell off my desk. Um, everything's falling off my desk. Every part of this project is open source, and there's pretty much something for everybody. So the Android application is open source. The firmware on the device itself is open source. The 3D printer designs for making cases, the ones that I've designed are open source. Yeah, every part of it is open source, the PCB design. So, if any one of those four things sounds interesting to you, there's probably something that you could contribute to the project or that you might enjoy on the project. If none of those things sound interesting, you could probably still have fun just using the device. So that hopefully there's something everybody will enjoy. This always comes up. Since I don't make any money off of it, I also don't provide kits. So on the website, kv4p.com, which you'll see in most of the slides on the lower right, just to remind you, there's a quick start guide where I do provide links to all the latest parts that, as of the best of my knowledge, are still available. But any of you who have put together kits, whatever, certain components run out. So I try to keep it fresh on a weekly basis to make sure you can buy what you need to build one. So with that, let's get started. I'm going to do a little live demo. Some of you may have seen the YouTube videos. I'm not going to do a full demo. I will talk a lot about the project. The one demo that I want to show that I think is maybe the coolest of the demos is how it does APRS. So first, for those of you who are not familiar with the project, really basic stuff. So it is a device that plugs into the back of your phone. So it sticks on the back with a piece of like sticky gel pad that doesn't leave any residue. And it connects to the bottom with a little USB-C adapter. So you can see this little U-shaped adapter here. So it just kind of piggybacks there, and it turns your regular smartphone, your Android smartphone, into an HT. It's a 1-watt HT, so not high power. But if you use a small antenna like one of these guys, you could, listen to your nets while you're out and about, put it in your pocket. It's just like something you could carry around like your regular cell phone without pulling out the HT in the middle of your job or whatever. But you could have this thing and nobody would really blink an eye. So anyway,
We're
that's the
not
basic.
seeing anything.
You're not seeing, well, there's nothing on the slide. Oh, you know what? I should stop sharing my screen while I'm showing you things in person. Let's stop. How do I stop? Okay, here, stop share. Like I said, there we go. Okay. You probably saw in a postage stamp size what I was trying to show you. But yeah, so this is the actual hardware part of it. I'll pull it off so you can actually see it a little bit better. Like I said, it sticks to the back with a piece of sticky gel pad, and the PCB is inside there. This is the 3D printed case that I provide the design for. There's already other people who have provided other designs as well. It just sticks on the back of your phone with that gel pad. And then you just take one of these, either you take a USB cable, which is totally fine, or you take one of these little U-shaped USB-C adapters, and you use that to connect it to your phone's USB-C port. And the magic of it is that the radio device itself has no battery. So unlike an HT that you have to remember to keep charged, you could throw this thing in your car's glove box and it would work a year from now if you forgot about it. You just plug it into your phone. As long as your phone has a charge, this thing will work, which I think is pretty cool. So once you get it plugged in, the app starts up. This is just a test phone, so I don't really have many memories in here. But if you had memories, they'd all be listed here. You can have different groups in different locations if you travel or what have you. But the demo I really want to show you is text chat. So of course it supports voice, regular FM, analog voice. I do plan to add UHF before the end of the year for sure, but right now it's VHF, 2-meter. But I want to show you text chat because I think text chat is actually the cooler of the demos. So most people, when they hear APRS, they think of like location tracking on a map, which of course APRS is wonderful for that. But what a lot of people either don't know or they don't use it for is that APRS can also do text messaging, very much like SMS on a cellular network. And it even has some kind of lightweight mesh networking where people nearby will rebroadcast when you retransmit when you send an APRS message. So it's perfect for use cases like this, where if you're like out hiking with some friends or just, off the grid, you can use your same cell phones to text each other and, say, hey, come check out this thing I found, whatever you want to do. So I want to show you how texting works on this using APRS in the background, although you don't have to know anything about APRS. So here's what I'm going to do. I'm going to hold it up here. I know this is not ideal, but you'll be able to see how this works. I'm actually going to go to the home screen. I'm going to do hard mode here. Hopefully the demo gods will align with me. What I'm going to do is I'm going to, let's say you're doing something else on your phone. I don't know. You're on your web browser. Let's open up the web browser. So the app is still running in the background, but you're doing something else on your phone. And I'm going to use, this is just my HT that has APRS on it. I'm going to send an APRS message. It's just the regular old APRS protocol that, a lot of our radios have. So you could use any APRS device to send to it. And I'm going to address it to myself. And we'll see, like I said, if the demo gods will align today. And I'm just going to send test. Let's give it a shot. Okay, here we go. So what I want to, this is really washing out. Let's see if we can get it to show up. Okay. Okay, you heard it come through. Okay, now, here's the interesting bit. I'm going to pull down the notification shade on Android. Let's see if I can get this to show up. It's a bit washed out there. It may be backwards, but you can see there's a notification here, just like a text message. You get a text message, a notification pops up that says so-and-so sent you a message. This pops up and says, this call sign sent you a message, just like a regular SMS, which I think is pretty cool. And then when you go into the application, in the chat screen, there's your chat log. And just like your messaging app on your regular cell phone, you can see all the messages that have come in. So there's a lot of things that this can do, but I just want to show things like this. And texting from here is as easy as texting from your phone. I had to type out that message on these itty bitty little number keys over here, and it was really a pain in the butt to even write the word test. But on here, I could write out a full sentence as fast as I could on my email or anything else. So the idea is if you integrate a lightweight radio with your cell phone, there's all kinds of cool features that people can build in the future, whether they're people who like to tinker with hardware or people who tinker with software or people who, somewhere in between. So let me go back to the slides and let's talk a little bit more about how this project works and how it got to where it is. So let me share again. Here we go. Wonderful. Okay, so I worked on this project for about a year before I released it publicly, nights and weekends. So on and off, I probably could have done it in a month if I was working on it full time. But it took me about a year. And I really wanted to carry it around in my pocket for a while and make sure that it really worked and that it was kind of a useful thing before I put it out into the world. And I will say throughout that year, I doubted that this thing could actually work almost the entire time until 5 things kind of clicked into place. And I said, oh, this could actually probably work. Like, let's release this thing. And I want to kind of walk you through those 5 things. So the first thing that I stumbled on are these radio modules. So I'm an amateur at electronics engineering and PCB design. It's definitely not something I, professionally do or study. So I'm very interested in it. So the idea of building an FM radio from scratch at the PCB level, maybe someday, but I'm currently not there. So when I discovered that there are actually several manufacturers of FM, analog FM radio modules out there, basically an FM radio on a, I don't want to say on a chip, but in a little pre-made module that you can solder on your board, I said, oh, that's really interesting. Like, I've always wanted to experiment with building my own radios. What if I played around with one of those chips? And then one of the first experiments that I did is I soldered just a USB cable to it in a particular way. And I said, I wonder if the Android phone that I have can power this. And I plugged it in and it powered up. And it wasn't really doing very much yet, but I was like, oh, okay, this is really interesting. Like, what could we do with this? So the next thing that I discovered is you really need an intermediary between the radio module and the Android device, because the Android device, it's an Android application written in Java, right? It needs audio bytes in a certain format that are delivered in a certain way. Like, it doesn't speak to a radio module. It doesn't know what a radio module is. So I knew I needed something in between, some firmware basically that could speak the language of the radio module and translate it into something that Android could work with. So I started taking a look at microcontrollers, which I had used in past projects. to see if there were any that had the features that I needed. And what I really needed was I needed a microcontroller that had an ADC and a DAC built in because I wanted to keep this thing simple. Of course, I can add an ADC or a DAC discrete on my own PCB, but I wanted to try to keep this thing very approachable and very simple. I ended up finding this ESP32 microcontroller called the ESP32 Room. I don't know, it's a weird name, but it has exactly that. And it has some other things that are really wonderful too that are required. It's a dual core microprocessor, which means I can be doing some application logic on one core and the other core can be steadily streaming audio very, very quickly in the background so that we don't get choppy audio. And it also has a really, really stable serial connection over USB. So I found this microcontroller, and that was a major aha. I said, hey, this seems to have all the pieces I need to actually build something really cool. So I got it actually working like really roughly, probably in the first month of tinkering around. Like I had those first two ahas pretty quickly. I put one together kind of like dead bug style, just all the little legs of the various components stuck together with solder, not on a perf board or anything yet. I just wanted to see if they could talk to each other and if I could get this thing to work. And I got it to actually work at 8 kilohertz audio in that first month. So when I first heard the crackle of the static, or I heard the repeater in our area here come on, that was really a magic moment to hear that happen, because that showed that the radio module could communicate with the microcontroller, could communicate with the Android app. Like, this is possible. But 8 kilohertz audio is not very good audio. And even at 8 kilohertz, it also had popping and dips and all kinds of problems with it. But like, it was there. I could understand what people were saying. So I actually spent probably 4 to 6 months of that year learning how to perfect the audio. A major portion of that was I spent several months trying to implement my own data handling. So now I'm using APRS, as I showed you a second ago. I originally was implementing texting as BFSK, but my own implementation. I learned a lot doing that. I did eventually get it to work, not well, but I got it to work. But what it forced me to do was it forced me to actually look at the audio bit by bit and see if it's actually receiving what I'm sending, and fine tune every single little aspect of the audio chain until what I received was as identical to what I sent as possible. And so even though I didn't end up using BFSK encoding for my texting, I ended up with crystal clear 44 kilohertz 8-bit audio after that exercise. And so because of that, any off-the-shelf Java library can work with that audio stream and do all kinds of amazing stuff with it now. So really good audio quality now. And that's what let me start taking a look at AX25 and APRS. I knew that there were libraries out there. I played around with them earlier in the project, but because the audio was so poor originally, they couldn't encode in that and they couldn't decode from that. But with this crystal clear audio, it just worked immediately. And that was a really magic moment where I saw the first AX25 packet come across, and I said, okay, I can piggyback some APRS on this. Like, let's do this. And then finally, the last aha that made me say, hey, this is something other people could use, and not just people who are willing to open multiple software development environments and load this thing up, is I discovered that someone made a web-based firmware flashing tool for ESP32. So I was really concerned that I was going to have like a 10-step checklist for people who were going to have to load up my firmware into an editor, set all these settings, upload it, which some people would do, but it probably would be like maybe 5% of the hams out there. But I found this web flashing tool where you literally just click one button on my website and it pops up and it says, choose your device. You choose your device, and then it uploads the firmware in about a minute. And that was the last aha where I said, okay, if I polish this thing up, I think people actually could use this at this point. And really, the challenges were not over. So I announced the project. I posted the videos on YouTube. I'm not a YouTuber. Those are the first 2 videos I've ever posted. At that time, though, the harmonic suppression was not really where I wanted it to be. It was legal, but only just. So at the time when I released those videos, I did have a little bit more than -40 dB on the second harmonic, which is the bare minimum for a low power VHF transceiver. But also my main signal was very attenuated. So it was just not great. I mean, I was okay with that because at that point I was really just trying to get the whole chain of communication to work in the thing, and then I could refine this. But when I unleashed the gate of people very interested in this project, I was ashamed of the harmonic suppression. And so I spent the next 4 to 6 weeks doing several PCB iterations to get this better. And in the latest version that I designed, which is 1.7B, I now on the second harmonic have almost 53 decibels lower on the second harmonic, and you can see on the graph the further harmonics are basically non-existent. So this is very compliant with lots of room to spare. The good news is that this filter also allows more of the main signal power to go through. Almost the entire 1 watt is getting out at this point, which is really wonderful. At 1 watt, you want it all to get out. But this was hard. Hey, like I said, I'm very amateur at PCB design and learning about filter layout, which is really important. The reason 1.5 didn't work great is I had some of the components too close to each other, and so they coupled, and so parts of the filter were being skipped. Didn't know that, but I learned that pretty quick. And so, yeah, anyway, this was a tricky thing. Now, I thought that was going to be the hardest thing. I thought, oh, this is the peak of the mountain of challenges. But really, the biggest challenge in this project since I launched it has been this. So all through the year when I worked on it, I had been ordering my ESP32 development boards from Amazon. The same page, seemed like an unlimited supply. I ordered multiple batches of them because I was messing them up and, doing whatever. And I thought nothing of it. I thought, hey, Amazon, big supplier, ESP32, very normal microcontroller that everybody uses. This is not going to be a problem. Within 1 week of me posting those YouTube videos, Amazon was completely out, 100% out of that particular dev board, and nobody else sells that exact same dev board. So there was a scramble after that to figure out, well, okay, how do we get all of these, thousands of people who are taking a look at this project the ESP32 that they need to actually build one of these things. And so I started looking for alternatives, and there's a lot out there, but they're all slightly different. So that one on the left is the one that I started with. It's a 38-pin dev module. I call it the wide version, just because the pins are a certain distance from each other that I had planned for on my PCB. There's also another 38-pin one that a lot of people bought on their own, just being like, hey, it's 38-pin, I could use this. But it's about, I think, 2 millimeters narrower pin spacing. And so in order to use that with my PCB, some hams have just bent the pin slightly, which works. The pin out is exactly the same, but boy, that's not very elegant. And then there's also a 30-pin version, which has all the pins that I need. It's actually the wider spacing, but of course the pins are laid out slightly different than the 38. And so you can't just drop that into the 38 and use it as is. So a lot of work. I did ultimately find some additional 38-pin that are the wider size. So that's actually what I recommend today for people who are building the project. And if you go to KV4P in the quick start page, kv4p.com, that's what I linked to. There's a supplier on AliExpress that has the original width 38-pin. But look at this last thing on the right over here. The next thing that we learned is in the chat where everybody who's building these things gets together and shares what they've learned. A bunch of people started coming in and saying, I plug it into my phone and it doesn't see it. Why doesn't it see it? It doesn't even light up. It's like it's not powering it. And so we had several days where all of us were kind of scratching our head trying to figure out what was going on. And we figured out that many of the ESP32 dev board manufacturers have purposefully or mistakenly left out these two little resistors that I have circled here. These are needed for USB-C to request power from Android as a host. If those are absent, Android's like, you don't want power. I'm not going to give you power. And so as a result, their module just sits there and does nothing. We figured this out by I actually soldered some very, very fine wires onto the connector on one of the bad boards and added two resistors of my own and connected it to ground, and voila, it lit up and started working. So once we knew that was the problem, we were able to work around it. I showed you that little U-shaped connector. That U-shaped connector that I had been using for many, many months doesn't work with these boards because they're missing those resistors. The good news is, and it's actually really not bad news at all, is there's this different make of the same thing. Probably looks very similar on camera, but this has resistors in it. So even with the dev boards that are missing that, if you use this, your phone will recognize it and it will work fine. And that was a hallelujah moment because at that point, none of the PCBs that we had been working on were going to work for anybody. The nice thing about this, though, aside from it having the resistors, is it solves another problem that people had been asking for. And I doubt that it's going to come up on the video, but it actually has a female port on the side of it. So it's got two male Cs and it's got a female C. And what that lets you do is it lets you plug in power to your phone while you're using the HT, which is really nice because you can leave it on your desk and use it as a scanner or something, have it plugged in, your phone's charging, very convenient. So it actually all kind of worked out. But it's just been a nightmare with the different size development boards. I had no idea that with this amount of variability, and I had no idea that Amazon did not have much stock. This is what it looks like if you were not able to really see it when I was trying to hold up my blurry phone. So my day job, I'm what's called a user experience design manager. So my main job when I'm not doing ham radio is to try to make products as easy and accessible and usable as possible. And so really the part of the project that I enjoy the most is trying to make this kind of the easiest HT to pick up and program. And so you'll notice, it borrows a lot from typical phone applications, right? So if you look on the left there, there's your list of memories. They're all in the Durham group. You tap that Durham dropdown, you can change it to another group easy enough. You hit that plus in the bottom, you can add another memory, and it's just a little form that you fill out. There's no program. You don't have to plug it into Chirp or something and like learn how to do all that stuff. Just hit the scan button and it scans the active group that you have up now. Hey, you want to join me? My puppy wants to come. Well, she's not such a puppy anymore, but she's little. Hey. She always wants to join my meetings. And then that right screen is the one that I was showing you earlier with I call it text chat in the app to make it more approachable, but it's really APRS under the covers. Here's some other stuff that it can do. I already said, you don't have to program it in the traditional way. Let's see. Accessibility, that's something I want to talk about. So I also want this to be the HT that's easiest for disabled hands to use. So I already have a few accessibility features, and I would really like to add more as people tell me what they need. So the three that I have currently, the number one, the most flashy one, which I'll show you a video of in a second, is closed captions. So if you're deaf or hard of hearing, you can turn on closed captions and join your net or talk to your friends, and it will actually print on the screen words as if you're watching closed captions on television, which is pretty cool. You may not be able to speak depending on if you're completely deaf, but you can at least, follow along, which is pretty cool. I also have a mode you can put it in where push to talk becomes sticky, so it will stay on after you tap it. And then you tap it again and it will turn off for people who have like a hand tremor or any difficulty, with fine motor control. And you can also turn off animations because some people with certain neurological conditions, animations cause them trouble. I'd like to know what else it should have. So if there's something else that you'd like, let me know. I did also test it and fix a lot of bugs with a screen reader. So if you're a screen reader user like a blind ham, you can actually use your Android phone like you're used to, and this application will work normally, and you can use it to talk to people on your radio. Something I just launched, actually just a few days ago. Earlier, I told you one of the big ahas was I found this web firmware tool. You don't even need that anymore. So I spent the past few weeks actually adding to the Android application the ability for the app to flash your firmware. So what that means is whenever you download the latest app from Google Play, you're also getting the latest firmware. And if there's any changes, it will just pop up and say, hey, there's a new firmware, tap this button, and it does all the flashing for you. There you go, puppy. I want to show closed captions. So for those of you who haven't seen the YouTube video, I have this queued up just to the part where I show the closed captions because I think this is a cool thing for people, like I said, with any hearing challenges or for people who know hams with hearing challenges. So what you're going to see is I was listening to a morning net and you'll see me turn on closed captions and you'll see the closed captions for the net. Let's see if we can get this to go. My clear repeater system on this morning. So I thank you for getting me in this morning and say top for the morning. And the answer to the question is sadly no, but I got a good relationship with them. It's something I always give them water, and at Christmas I always bring them out some holiday cookies or something there. So that I don't. All right, I'm going to stop it there, but if you look at the middle of the screen there, you can see that it was adding closed captions as the person was giving their net update. So this is actually a feature of Android that most Android phones have, some don't. But if your phone has closed captions, you can turn it on from the KV4P app, and you'll get closed captions whenever someone talks, whether it's a net or just simplex or whatever. So pretty cool. Skip to the next slide here. Okay. So it's been 6 weeks since I launched the project. I've, like I said, I'm not a YouTube person, so having 100,000 views on my 2 videos was pretty surprising, especially in the ham community, because, I don't know that all that many hams are watching YouTube. So I feel like probably all the hams that watch YouTube have probably seen the videos at this point. I thought that was pretty wonderful. So all I can do to keep up with the questions people are asking. The project was reviewed by the 3 biggest YouTube ham radio channels. Some of you may know some of these: Ham Radio Crash Course, Tech Minds, and what's his name? He didn't put it on his home screen here. The Old Tech Guy, I think is what he calls his channel, that 3rd one. All wonderful, really nice folks who managed to show the device for people. There's been articles in a lot of major online publications. And in our chat, which is where we provide like community support, like I said, again, I don't make money, so I don't provide like official support. but we have 1,000 people in there. There's literally 1,000 hams sitting in the chat, helping each other out. Like, hey, I just got my PCB. This looks a little bit weird. How do I do that? That's how we figured out the resistor problem. There's a bunch of people who chipped in together and figured it out. There's a bunch of people in there working on new features right now. So if the project interests you, but you're concerned that like you don't know who to ask questions, jump in the Discord chat, which I link to on multiple pages on the website, on the quick start guide, on the contribute guide, all that stuff. And there's a lot of people who've actually started creating features and things for this. So I want to give you a sneak peek of kind of like what we've been doing lately and what's coming up. Again, it's only been out for 6 weeks, so hopefully this will show you the project's going to be moving very quickly, and I think it's going to have some really cool stuff very, very soon. The first one on this list, I cannot believe that somebody built this as quickly as they did. They actually did this within the first 2 weeks of me launching the project. Someone built a Windows client, which does away with the Android phone altogether. So you plug the KV4P HT into your Windows computer, you run their piece of software, and it basically turns it into like a sound modem. So you get an audio in and out device on your computer, and you can transmit, you can receive from your computer, and that means you can do any of the cool stuff that you can with that, like SSTV or whatever. I cannot believe someone put that together so quickly. I didn't even support them. They just like, it's open source, so they're able to look at my code and figure out how everything worked. People have created new 3D printer designs. Some people realized the ones I made were not that great. I don't know, they work for me. But there's some professional, 3D designers out there who are in the project now making some really cool stuff. There's a bunch of stuff that's actively in progress right now. Actually, earlier today, I was working on better APRS support. So what you see here on the screen that I'm sharing, on the two screenshots on the right, are what it will look like in the next version. So I showed you earlier, you can get a text message already, and it will notify you, which is very cool. But APRS can do so much more. There's probably, in my area, there's weather stations that are like, beaconing what the weather currently is in that area. There's people reporting their location as they drive down the road. There's, ham repeaters saying, hey, there's a net on this day. There's all this kind of cool stuff. And I want to make sure that the app shows it in a way that people will understand. And so as of the next update, it's going to look like what you see on the right over here. So for example, if you look in the upper right, that's what the weather APRS reports will look like. Hopefully pretty easy to digest and see as it goes by. The chat message on the left, you can see it looks more like a traditional like chat bubble like you would see on your phone with nice, big, easy to read text. So I just want to make things, again, really easy to pick up. And I'm almost done with that. So fingers crossed. Now that I've said that, it'll probably take me another 4 weeks, but I think I'm almost done with it. There's a professional electronics, and actually several professional electronics engineers have joined the project as contributors. One of them has fully redesigned the PCB from the ground up, which hallelujah, because like I said, I'm very amateur. But what they did, especially that's important, they did away with the need to buy a dev board. Those ESP32 dev boards that are on all those different sizes that like work differently. They put the ESP32 module directly on their design. And the module is consistent. Like that's directly from the company that makes ESP32. Those don't vary. So that means when you buy one of his, he's going to sell these, which, hell, I mean, you still have to buy the board even if you're getting your own because you need to order it from a board manufacturer. So pay him a little bit more and you'll get one that's guaranteed to work with the right chips and everything. And I think that it doesn't come with a radio module, so you still get to do a little bit of self-assembly yourself. There's another developer who joined the project who's way better at firmware development than me. So, hey, I got it to work. The audio is nice and clean. But they looked at it and they said this could be much better. So they've been actually spending the past few weeks just cleaning up the firmware and rewriting it to be much more maintainable, much more efficient, and it will open up all kinds of cool stuff in the future. One of the things he's really excited about is with the new audio streams he's implementing, we may be able to do full duplex VHF, UHF, which would be amazing for a really low cost HT because you could use it then with satellite communication. So that's one of the stretches I'd really like to see happen in the next 6 to 12 months. And I think the work that he's doing on the firmware will probably make that possible. I want to add an AX25 terminal, for communicating with like local BBSs and other kind of packet networking sorts of things. I actually think that'll be almost trivial because the APRS stuff I have already uses AX25. So I really just need to add like a keyboard input to that. And then finally, I've been talking to Repeater Book. This has been a top request. It's something I wanted to actually have before I launched, but they just didn't quite have the API that I needed. But they're interested in providing access for a one-button tap that will use your phone's GPS and automatically add all the repeaters as memories for you instantly. So that's probably within the next few months, I imagine we'll be adding that. So some kind of cool, exciting stuff coming up, a lot going on in the project. At a high level, here's the things that I hope the project will do. I hope it will attract more young people to the project, to ham radio. the ham radio, not the project, because the things that I'm using are pretty approachable for someone who's a tinkerer or a maker. So I'm using Arduino IDE to program the firmware, which is like what a lot of even school kids use to learn programming. So anybody, even if you don't understand all the code, you can open it up and you can get a basic idea of how this thing works. It's an Android application written in Java. Lots of people program in Java. Lots of people develop Android applications. I hope that piques some of their curiosity to say, hey, let's check out this ham radio thing. I think I might be able to do something kind of cool. I also, this is kind of a long game, but when you think about it, if we get to the point where this $35 radio, which is what the components end up costing on a unit basis, if it can do all of this stuff, APRS, potentially UHF, maybe dual band in the future, AX25 terminal, like if we can cram this thing full of features, I think it's going to force at some point HT manufacturers to up their game, because right now they're charging a premium for a lot of this stuff, and we can show that we can just give it away for free and we can all build it together. We don't need them, so they're going to have to offer something pretty exciting for us to buy their products. I don't know. We'll see what happens there. But I think right now, like if you want to buy an APRS capable HT, there's really not many that are very good. If you want to buy an HT that can connect to your computer and be used as a sound modem, there's not too many. If you want one that can pair with Bluetooth, which is another thing we're working on, not too many. So who knows? I don't know. I'd love to see that be the case. I'd love the industry to say, hey, we can do this stuff too. And if they want to rip off our code, that's okay too. Like part of the reason I'm making it open source is so anybody can do it. And I'm totally okay with companies taking it and making it and selling it. It's under GPL3, which any of you who know about open source, what that means is if a company does use the code and modify it, they have to release the code that they modified. So they have to release their code too in order to be compliant with the license. And I'm totally okay with that. I think that would be incredible if companies did that. And I just hope it advances ham radio. I hope people build some cool stuff with this. That's it. Like I said, big community, living project, lots of people working on lots of really cool stuff. It's only been in the public for 6 weeks, so I think you can see it's moving very, very quickly. That's what I've got as a presentation, but I'm happy to answer any questions if anybody have thought of any. Thank you for letting me share with you today, and I'll turn off my share so that we can see each other better. I don't know how this all works. If you got like a hand you can raise, or if you just speak up, I don't know. Somebody who knows Zoom better can help me. Looks like Jean is the first with their hand up. I did see something pop up.
Yeah, good evening. I was having some trouble with my video. Great presentation. Number one, can this be used with an old data phone that is not on any type of network, whether it be a data network or Wi-Fi? And number two, is this strictly a case system, or can it be purchased already constructed and pretty much ready to use right out of the box when it comes in the mail?
Yeah, those are two really good questions. So I should have started with it. It's completely off grid. So of course you need to connect your phone to Wi-Fi once to install the app, like that's a given. But once you've done that, you can put it in airplane mode and it will work completely forever without any internet connection. When we do add things like the repeater book integration, I will always add them as optional, meaning that the base capability of the radio will always work even without an internet connection. And if you have an internet connection, great. Maybe you can send APRS messages to the internet on behalf of people who don't, or maybe you can get repeater information from the internet. But if you don't have it, the radio itself will continue to work. So it's completely off grid. To your question of, you have to buy a homebrew, like, is it fully homebrew? Currently, it's fully homebrew. But as I mentioned, that the professional electronics engineer who has a side business doing this kind of thing, the 2.0 version of the PCB that he's working on, he plans to sell as a kit that is almost completely built. So I believe that everything will be on the PCB other than the radio module. So all that means is you buy his PCB, you buy the radio module, a few little dabs of solder, and that's it. I don't think you're going to get much easier than that, because if someone sells pre-built units, they need to get certification, because then it's a commercial product and not a homebrew kit. So that's probably as good as it's going to be unless some company wants to commercialize it fully. Yeah, but that's coming soon.
Good presentation.
Thank you. Appreciate it. I see Dan has his hand up.
Yeah, I just wanted to say thank you. I was getting a rush from the excitement you conveyed about when you figured stuff out. Old school true believer for open source.
Awesome.
So
Yeah, I love to hear it. Yeah. It's been peaks and valleys of despair and excitement throughout the project. I'm sure anybody here who has tried to build something that they weren't sure they could do has experienced that. But yeah, and I'm glad that all those little checkboxes got checked and this is something that can actually exist in the world. I'm glad that that's the way it ended up. Dave, I think you had a question. What's up?
Yeah, before I mentioned DMR, and of course, I was just kind of pulling your chain because that's a codec that is uh, not open. On the other hand, I wonder if you've been following the M17 project. That's all truly open source and uses an open source codec. I
Mhm.
also was just curious if you'd ever heard of Bruce Perrin's White Box project. That was, I think the last time he even talked about it was about 4 or 5 years ago, and I don't know that it ever went anyplace.
Well, I've never heard of the White Box Project, so I'd be interested to hear about that. But I am familiar with M17. So within the first week or two of the project going public, the one of the creators of M17 reached out to me to see if there was an integration there. He was honest. He said, "Hey, I'm busy enough with my own project, but this seems like it could be an interesting thing for you," which I appreciated. And I had already heard of M17, so it wasn't news to me. It M17 could be integrated with the project, but here's the challenge. M17 requires you to modify the radio module itself. So they do use the same radio module as I am. However, they have custom firmware for the radio module. So you have to be a pretty technical ham to actually solder on wires to the radio module and know how to program it via those wires. So definitely possible. And maybe if someone, for example, pre-programs those chips and sells them as a kit, then we could do it. But I'm just trying to make it so that most hams feel like they could build this thing. And today, I think that bar would just be too high. But maybe one day. But tell me about the other thing. What's this white box project?
It was something that Bruce and his open source buddies decided that they were going to try to put together to have an open source radio with codec 2 in it,
Hmm.
which is and essentially go from there. And I don't know that it ever really got much off the ground. I think it was pretty early on. And I think at the time, why they're just, nowadays what happens is you get these, like you say, the DA part and the ESP32 and all that stuff, and you can just kind of put 3 or 4 pieces together, and voila, you've got a radio. And
Yep.
then the rest of it's all the firmware, and of course, that's always been the problem.
Hmm.
So, I would like to be able to experiment with M17. I actually have a particular handheld here. Um, I don't remember what the model, an MD380, I think it is, and that's one of the ones that you can modify to do this work. So
Cool.
that's one way of kind of getting at it. But it would also be nice to have something like one of your open source projects because it would provide a very cheap and easy way for people to get in to running M17 within their local club and being able to experiment.
Yeah, no, I'm definitely interested in coming back to it in the future. But yeah, initially, my initial take was, I think that's going to turn away people initially. But yeah, I want to come back to it. I'm also interested in looking at other codecs. Like I know it's on HF, and this may not make sense technically, but something I've had a lot of fun with on HF is FreeDV. I don't know if anybody has played with FreeDV, and maybe it uses codec too. I'm not sure. But
Yeah.
it's a very low bandwidth data voice mode that can work on HF. And like we're really talking low, because it's HF, it's low, really low bit rate, like hundreds of baud basically. And I know for sure that my radio can do 1200 because that's what APRS uses, if not faster. So I'm kind of curious to pick apart FreeDV and see what they're doing because maybe there's a codec that they're using that I could use. It wouldn't be as high quality as M17, but it might be something you can use out of the box without modifying the radio. So yeah, I'm really excited about that stuff. I think that data stuff is some of the more interesting stuff that can be done with this. So
Now, the free DV crowd, by the way, hangs out on 14236 on the 20-meter band. So, and you can, of course, download free DV for yourself, put it on a Windows system, and hook up an audio codec or whatever from your radio to it and experiment with it that way. And that's another one of Bruce Perrin's projects.
really, okay. Yeah, I mean, I have used it as a consumer of free DV, but now that I have a project that could potentially use it technologically, I should look a little bit deeper. Yeah. Cool. These are all great questions. Any other questions? I don't see any other hands up, but feel free to just unmute. And I know people will watch this as a recording later, so if anybody watching this their curiosity is piqued, I would just encourage you to go to the website, jump on the Discord, either build one or contribute with us. There's a lot of really smart, interesting hams in there.
It's been a great presentation. I appreciate you doing this.
Well, thank you so much, Dan. I appreciate the invite.
I hope you'll come back. I see Dan's here. He always got a question. California Dan. And he's bashful right now. All right. Looking around, I don't see anybody got your hands up. Nobody's asking questions. So we'll probably have to pull the plug here, or we could just chat. That's a great project, and you have a strong ability to stick with things. That's an important part of those projects.
Yeah, I think that's a big piece of it. Yeah. But yeah, like I said, anybody's interested, pop in the chat, see what's going on. If it doesn't currently interest you, check back in 6 months because it's going to do a lot more in 6 months.
Does the closed captioning work without a backhaul? Is it also completely independent and off grid?
I believe so. I haven't tested it, but I believe so. I'm pretty sure that feature is on device. Yeah. Like, give it a try, it's not like I said, it's a feature of Android. So you could actually go into your phone's accessibility section and turn on, it's called live transcribe. If you see that there and you put your phone in airplane mode and it works, then that answers your question. What I'm doing is I'm providing a shortcut to that system service via the app because I don't think a lot of people know about it. And I think hams who are hard of hearing would appreciate being able to try and close captions. But you can test it without even having the KV4P radio. Yeah. Well, thank you so much again for having me. I appreciate it. And I look forward to seeing what else is on your show. Like I said, I'm impressed that you've done this for so long with so many interesting speakers. So I'll have to keep tabs.
Over 400 and growing, and it's been an interesting journey. I started out by myself, added a crew, a team, and the team that does. Without the team, we wouldn't have what we have. You know how that works. Well, when you're ready with the updates and such, get a hold of us. Fill out that little deal, pick a date, and we'll get you back out here.
Awesome. Well, I appreciate it. Have a good day, everybody.
All right, 73s, everyone. Oh, wait a minute. Go ahead, Dave.
No. I was just waving by.
Oh, okay. And by it is 73s.